Here's an example problem, just like the ones on page 319, numbers 1 through 5 you're going to be dealing with. How much less energy is needed to convert 50.0 grams of solid aluminum to a liquid compared to converting 50.0 grams of liquid aluminum to gaseous aluminum? I'm going to use latent heat equation 2 times. First time I'm going to go from a solid to a liquid. And the latent heat for this one is going to be the latent heat of fusion. And the second one I'm going to use is going from a liquid to a gas. And here it's going to be the latent heat of vaporization. So the table I gave you, the masses are in kilograms. So for both of these, I'm going to take the 50.0 grams, convert it to kilograms, and that's the mass I'm going to use in both cases. Latent heat of fusion is going to be the 3.97 times 10 to the 5th joules per kilogram. This mass is also in kilograms. Let's move this one down below. .0500. Latent heat of vaporization for aluminum going from a liquid to a gas is 1.14 times 10 to the 7th joules per kilogram. In both these cases, kilogram is going to cancel out. And I can now find how much heat is needed in both these cases to change between these states of matter. 0.05 times parenthesis 3.97 times 10 to the 5th. First case I need with 3 sig figs, 19,900 joules. And in the second case, which I should need a lot more, I need 5.70 times 10 to the 10 to the 5th. Change this to scientific notation for clarity. 1.99 times 10 to the 1, 2, 3, 4th. Then the last thing I need to do is just subtract these two values. So how much more heat is needed? Well, that's going to be 5.70 times 10 to the 5th minus the 1.99 times 10 to the 4th. And what we get is I need 5.50 times 10 to the 5th joules more heat to go from a liquid to a gas. Makes a lot more sense because once a substance is in its liquid form, the particles already have kinetic energy, so it takes a lot more energy to get them to release some of that potential energy that could be stored between the molecules. So hopefully this helps you solve page 319, 1 through 5. See if you can come on Wednesday with the best guesses on those questions. Have a good morning.